Okay, so today we are going to solve a problem that is actually based on work, power, and energy chapter. So let me first read out the question. So this person is lifting this 25 kg block with the help of this rope, and it is given that the mass of the block is 25 kg, and the pulley is frictionless, and the person is walking horizontally. That means this string is going from this point to this point, this horizontal way. The person walks 2 meter, and the angle of rope will change from 60 to 30 degree, that is given in the figure itself. If the block rises with constant speed, block rises with constant speed. So whenever in this type of question it is written with constant speed, one thing comes to our mind is that the kinetic energy will never change. Kinetic energy doesn't change, and from here you will get one intuition that if kinetic energy will not change, then we can one thing we can apply is work energy theorem. So first we will read the question and then we will see whether we can do this or not. So here they have given that block rises with constant speed. The work done by the rope on the person when the person moves by 2 meter, means we have to find the work done by the rope on the person. So if directly we will first I will say that I will go for drawing the FBD of both the person, the block, and also I will draw the FBD for the rope. So they have given that this string is light, so string is light and inextensible. That means if it is light, it cannot store kinetic energy. If it is inextensible, it cannot store potential energy. And if they cannot store kinetic and potential energy, if anything that cannot store energy, so it cannot do the work also. That means work done by the rope will always be zero. Total work done, net work done by the rope. So anything, if a person is doing some work, that means he or she is having some energy within him or her. So this rope cannot do work. That means net work done by the rope will be zero. It cannot store energy. Now if I will draw I am going to draw the FBD of man and the block. So here we have the block. On block there are two forces basically. So this is the tension force from the light string. From here the gravitation force. For person there is like you can say there is one force, this normal force from the ground, then gravitation force, then tension force acting at some angle. So this angle is changing actually. This angle is changing from 60 degree to 30 degree. So this theta is changing. That is the main issue in this question. So if you have, I will go directly applying work done formula. If theta is changing, so then we know that we have to integrate it somehow. And so we will solve this by both the methods. First we will solve by the formula. If we know that I have to integrate this theta, because this theta is changing. Tension, for tension if I will say this block moves up with constant speed. They have given constant speed. So constant speed means what? That there is no acceleration, because this is moving in a straight line with constant speed, means no acceleration. Net force will be zero. So tension comes out to be mg. The block mass was 25 kg and g value given here is 10. So that means tension is 250 Newton. Now we know that the tension in the string will always remain 250 Newton, because for this block, if we consider this block, the speed is constant, and constant speed means net force is zero. So tension will be always 250 Newton. Now this person will experience a force due to string, this tension force, same tension force T, but this angle is changing. So work done, we have to find the work done by this tension force on this person, because in question they have written work done by the rope on the person. So work done by tension on person, this will be what? This will be integration of T dot ds vector. So the person is moving in this direction, so we will consider a small displacement ds displacement, and the tension is acting in this direction. This angle is theta. So what is the angle between tension and this small displacement? We are taking a small displacement because we know that the angle is changing, and if angle is changing, that means work done for all small displacement can be different. This angle is theta. Now here in this case, if I will do if I will write T dot S, so T dot S, this angle is 180 degree minus theta. So this will become T ds cos 180 degree minus theta. So here I can write T ds cos 180 degree minus theta. So here I can write T value, we know that tension will be always 250 ts cos theta, cos 180 degree minus theta, minus cos theta, sorry, minus cos theta. We have to integrate this. Now what I will do is this ts cos theta. So first we need to find a relationship between this ds and cos, because here we have two different variable, ds and one is theta. So ds and theta, we cannot integrate this directly. We have to either convert cos theta in terms of ds displacement, or we have to convert ds into theta, some function of theta. So what I will do is here as we know that this person, the angle changing from 30 degree to 60 degree, 60 degree to 30 degree. So what I will like, if we can do is we can draw a triangle like this. This angle is theta. We can consider this as S. So now what we can do is yes, we can say that this value we can take as h. So h here is constant. H is height of pulley from this horizontal line. So we can try to build some relationship between s and theta. What we can do is here is h s by h is equals to cot theta. Here we can write s is equals to h cot theta. Now I can differentiate this, ds by d theta is equals to h minus cosec square theta. That means I can write ds is equals to minus h cosec square theta. So here now we have to integrate 250 minus h cosec square theta minus cos theta. And now we got sorry, here it will be d theta. So first I will discuss this method, then we can go by different method directly. We can apply work energy theorem, but this is the basic method, so I am discussing this method also. So here I can write 250 minus h cosec square theta d theta minus cos theta. So here what we will get 250 into h integration cos theta divided by sin square theta d theta. Theta varies from 60 degree to 30 degree. So now what task is left is we have to find the value of h. H we can find from this triangle. So here the angle was 60 degree, here this was 30 degree. They have given this as 2 meter. They have given this as 2 meter. So we can consider this side as h, this is x. So tan 60 degree, we can write tan 60 degree perpendicular by base, h by x. Tan 30 degree we can write as h divided by x plus 2. So from here we will get h is equals to root 3x. From here we will get x plus 2 is equals to root 3h. So putting this value here, what we can get, x plus 2 is equals to root 3 into root 3x. So finally we will get x is equals to 1 and h is equals to root 3. So here h is equals to root 3x, h is equals to root 3. So finally this integration becomes 250 root 3 integration. So here what we can do is we can take sine theta as t. Like you can do this integration by any way, whichever way you want. But here what I am doing is I am taking sine theta as t. So d theta by dt, what we can write this as cos theta. So d theta is equals to dt d theta is equals to dt by cos theta. Now this integration becomes 250 root 3 integration. So d theta, if I will write dt by cos theta, so cos theta will get cancelled out. We will get dt divided by t square from 60 degree to 30 degree. This integration you can do. So I am doing this integration here. 250 root 3, 1 by t square integration is minus 1 by t. So finally we will get minus 1 by t, and what is t actually? T is nothing but sine theta. So 1 by sine theta 60 degree to 30 degree. So this will become 250 root 3 minus 1 by sine 30 degree minus 1 by sine 60 degree. So this is 250 root 3 minus 2 plus 2 by root 3. So finally what we will get from here is minus 500 root 3 plus 500. So here I am getting 500 into 1 minus root 3. So we will see is there this thing there in the option, 500 1 minus root 3. So from this method we are getting option number 2, 500 1 minus root 3 joules. So now this was the basic method of finding the work done. We can try another method like we can directly apply the work energy theorem, because as we know that the total work done by the rope will always be 0. So we can go by method 2 also. Method 2, rope is doing work on 2 objects, first on the block and another on work done on the man. So work done by rope on man plus work done by rope on block, this will be equals to 0. So what we can do here is we will not find this one, we can find this one easily. How we can find this one? Work done by the rope on the block, because as we know that the block is going with constant speed, so we can apply work energy theorem on the block. Here work done by tension plus work done by gravity is equals to final kinetic energy minus initial kinetic energy. This is work energy theorem on block. Work done by tension is the work done by the rope plus work done by gravity. So gravity work done will be mg minus mgh. H is the height which this block is by which the block is going upside. Final kinetic energy, obviously it is final and initial both will be equal because it is going with constant speed, so this will be 0. Now what we have to find is by how much height. I am taking this as h1. By how much height the block is going up, we have to find this. So we can find it. It is not very complex task. This was 30 degree, this is 60 degree. We know this is 2. We found that this will be 1 and this will be root 3. So by how much height the block will go up, that will be this length L2 minus L1, because total string length will be constant. Total string length will be constant. So this is L2, this is L1. L2 minus L1 will give you the height by which the block is going upside. So we can now easily calculate L2 and L1. L2, how we can calculate is, we can write cos 30 degree is equals to this base divided by hypotenuse. So base is 3 divided by L2. Similarly we can write cos 60 degree is equals to 1 divided by L1. So we will get L1 is equals to 2 and we will get L2 is equals to, this is root 3 by 2 is equals to 3 L2. So here we can get 2 root 3. Okay, so this is 2 root 3. Now H1 will be L2 minus L1, that means 2 root 3 minus 1. So now coming here we can get work done by tension will be equals to mg h1. So this will be 25 into 10 into 2 root 3 minus 1. So this is 500 root 3 minus 1. So that means work done by the string on the block, work done by the string on the block is this much, and we know that work done by the rope on the man plus this thing should be 0. So that means work done by rope on man plus 500 root 3 minus 1 is equal to 0. From here also you will get your answer as option number 2. So that means this one. So there are two methods. First method was basic basic concept. I am just applying the work done formula. From there we found the same answer, that is for 500. So here in this case you have to do integration. If you don't want to do the integration or is to save your time, so you can go by this method, work energy theorem. Here, so I think this thing is pretty much clear for all of you. If you have any doubt, then please tell me.